Hello, hello, hello. Hopefully you remember that I am not here today because, well, it's been on the board since beginning of October, and we're now at the end of October. Tay has an appointment today, so I am not here, but we are lucky enough to get Chromebooks borrowed from the library. So, you need your math book and your math notebook. We'll be writing a new vocab word down. Not even new. You guys have done this vocab word before, but we're going to kind of add to it. So, in our notebook, flip to your next open page, and I'm not going to write on the back of a page. I'm going to write on the front of a page. So my spiral is at the left-hand side. This is my right hand because I write right-handed. This is it. I'm going to title it Unit 3 Vocab. Let's look. I think it's only going to be a part 1, but let's see. Unit 3. Let's see what all Unit 3 has. Yeah, it's just going to be a part 1 because it's all about the same kind of thing. So, we will have proportional relationships or proportional graphs, proportional lines. Proportional graphs. This is 7th grade. We've talked about it a little bit. It is a straight line. Goes through the origin. And has a constant rate. And that constant rate is actually our slope. So if you were to, I should have wrote it all to the side. That's okay. If you were to draw a graph, I went down 4, so I can go right across the middle one. That's a proportional graph. It's straight, it goes through the origin, and it has a constant rate of change. Our new one is linear. And they're really equations, linear equations. Proportional graphs are also, they're proportional equations too. Maybe we can write that. These are just straight lines. Most common, we will see y equals mx plus or minus b, which we have that in our notes. Maybe put a little note right here. See page before this, because that's the notes on that page. Linear can be this. That's straight. That's a linear line. It can be this. That's a straight linear line. That's green again. Where did my blues go? Huh. It can be this. And this one might be harder to see because it's orange, but we'll see. Can be that. These two almost look the same. This one's orange and that's red. That's it for your notes for new vocab. Maybe pause to make sure you have it all. Then in your math book, you need pages 181 to to 186. And I just did all of them. And look, I ripped it out like you guys. Except I didn't rip it all the way across. I just didn't rip it super, super straight. So, we will have this. You will have a what do you notice, what do you wonder? So you should have that should be capital. Noticed blank. I wonder blank. Take a minute to fill that out. Pause the video so you can actually fill it out. On to the back. A ladybug and an ant move at a constant speed. The diagram with tick marks show their position at different times. Each tick mark represents 1 centimeter. So at the start, they're at the same spot. Looks like it's the tip of their noses. After 2 seconds, there's the ladybug, there's the ant. The ladybug is at 1, 2, 3, 4. The ant is at 6. After 4 seconds, the ladybug is at 8, 9, 10, 11, 12. The ant is at 12. After 6 seconds, the ladybug's also at 12, but the ant is at 18. 1, 2, 3, 4, 12, 13, 14, 15, 16, 17, 18. 18. Lines U and V also show the position of the 2 bugs. Which line shows the ladybug's movement? Well, here's distance traveled. My guess is every single one of these is 1 centimeter, so we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And let's see. Alright. Sorry about that. So we are going to label these 1. So 1 second, 2, 3, 4, 5, 6. And then we'll figure out some points. Remember, points are where they... Let's zoom in. Oh, wrong button. Oh, maybe I can't zoom in. Okay, let's make this closer. Oh, that's bending the whole thing. I haven't made a video in a while, as you can tell. Okay. So, like this point right here. And this one right here. This bottom line was 6 centimeters in 2 seconds. So if we look back up here, 6 centimeters, 2 seconds is the ant. So that means this is the ant. And 6 centimeters in 3 seconds isn't on there. But this one's on there. 4 centimeters in 2 seconds. If you wrote it in pen, you don't have to erase it. It's fine. That means this is the ladybug. Which line belongs to the ant movement? Explain how you know. Well, we have the ladybug at 4, 2. 4 centimeters, 2 seconds. And we have the ant at 6 centimeters, 2 seconds. I shouldn't be writing in this color. I'm going to put it up there. Explain your reasoning. Well, we wrote that there, and it matches up here. Next, how long does it take the ladybug to travel 12 centimeters? So I'm going to go to 12, and I'm going to just draw a line going up. So, ladybug I don't know how to label it. Ladybug. 6 seconds. Ant. Here's my ant. 4 seconds. Okay, I think we're still on this page, but here. Scale the vertical and horizontal axes by labeling each grid line with numbers. We did that. Mark and label the point on line U and the point on line B that represents time and position of the bug after traveling 1 centimeter. 1 centimeter. Here and here. They're really, really close together. At that point, they're not much different. Okay. Now we're here. This is done. Why don't we answer this? How fast is each bug traveling? How many centimeters per second? This is the ladybug. This is the ant. Centimeters per second. So if we go up here, this is 4 centimeters for 2 seconds. And we want this to be 1, so we're going to do divide by 2. That gives me 1 second. Divide by 2, so 2 centimeters in 1 second. This one was 6 centimeters in 2. So again, we're going to divide by our 2, get our unit rate, which is 1. Divide our top by 2, gives us 3. So ladybug is 2 centimeters per second, and the ant is 3 centimeters per second. Will there ever be a time where the ant is twice as far from the start as the ladybug? You should try that one. Okay. 1.3 on page 183. Imagine a bug that is moving twice as fast as the ladybug. On each tick mark diagram, position the new bug. So twice as fast as the ladybug. So the ladybug at 2 seconds was 4 centimeters. Twice as fast, he'd go twice the distance. So we are going to be at 8. At 4 seconds, the ladybug was 8. Twice as far as 8 is 16. So at 4 seconds, we'll be at 16. 4. Using a straight edge. Again, I didn't tell you need one. Maybe I'll remember to put that in the notes before. This is a better one. We are going to connect these 2 points and the origin. Okay, so this part is done. Plot the position of the bug on the coordinate axes with line U and V and connect the line. Done. Write an equation for all 3 lines. Okay, well, we know their unit rates. And we know the new bug is twice as fast, so the new bug, what is the new bug going to be? So we have ladybug, we have ant, and we have maybe a spider. The ladybug, y equals, and then it's mx plus or minus b, and in this case we don't have a b because it's proportional, so our b is 0. And we were 2 centimeters for every 1 second. The ant was 3 centimeters for 1 second. And the new bug was 4 centimeters per 1 second. And you can prove it because 8 centimeters and 2. I don't know, it looked weird having that minus sign, so like there's like an arrow thing. This was 8 centimeters and 2 seconds. And if you find your unit rate, we get 4/1. Equation for each line, done. Graphing is a way to help us make sense of relationships, but the graph of the line on the coordinate axis without scalar labels isn't very helpful. For example, let's say we know that on the longer bike rides, Kyron can ride 4 miles every 16 minutes, and Mai can ride 4 miles every 12 minutes. Here's the graphs in these relationships. Without labels, we can't tell which line is Kyron and which line is Mai. Without labels and scales, we can't use the graph to answer questions like which graph goes with which rider, who's riding faster, if Kyron and Myra start bike trip at the same time, how far will they get after 24 minutes, This one we should be able to answer with this information, but then you're having to write equations. Doesn't make it any easier. There's a vocab word, which we know constant proportionality is our slope. Only one page. Alrighty. We are on page 186. We have Priya jogging at a constant speed. The relationship between her distance and time is shown on the graph. So this is Priya. Diego rides at a constant speed twice as fast as Priya. I don't know how to say her name. Sorry, guys. Sketch a graph showing graph showing the relationship. So you need to add his on this same line. A U-Pick blueberry farm offers 6 pounds of blueberries for $16.50. Sketch the graph. We don't have 6, we have 5. 30 is the multiple of 6, so maybe figure out how much is 30 pounds. So if we have $16.50 for 6 pounds, what would it be to have 30 pounds? What do we need to multiply by to get there? Graph it. Ooh. A line consists of the points -4. Oh, we can't get there. That's okay. I was going to say use this. -4, 1, and +4, 6. Decide whether or not each point is on the line. So this is based on a proportional graph. So you'll need to do your 6 minus 1 over 4 minus -4 to give us our 4/8. I said 4/8 and I wrote 5. 5/8 is correct. Alrighty, so our slope would be 5/8, and then you're going to set each of these as like a y2, y1, and see if they're equivalent to 5/8. 5 divided by 8, what is 5 divided by 8? 0.625? 5 divided by 8? 0.625, yes. So you'll set them each equal to it. Points 2, -4, x, y, a, and b all lie in a line. Find an equation that will relate them. If you want to look back in your book and see if you can figure that out, we've done very little with that. But we do know how to write the equation of a line. Y equals mx plus or minus b. And we know b is this. My guess is it's -5.5. And we can find our slope because A is a perfect spot and this is a perfect spot. So we have that going for us. Try it out, staple everything together, and make sure it gets turned in. If you finish this, log back into Google Classroom and check the next assignment there.